Hi there. Today's masterclass, I'd like to sort of introduce and welcome everyone because I see a few new faces in our in-world chat. The topic of each of these classes that I do is covering one particular facet of developing in either Unity or in Space, and trying to give you a bit of an overview on how that feature works and how you can get the most out of it. Now, today's class is going to be covering terrain. We're also going to look into water systems, but those are the real main focuses. So, terrain, pretty straightforward, used for representing real-world environments from a height map. The height map is obviously just a simple 2D texture that can be pulled up and down in varying locations. Now, to create a simple terrain in Unity, to begin with, we're going to just go to the Game Object menu, click 3D Object, and then we've got Terrain. And by default, Unity is going to leave us a bit of a blank, empty terrain that's not very interesting. Now, when you've got a terrain selected, you have access to the Terrain Inspector on the sidebar. The Terrain Inspector covers sort of all the bits and pieces, such as here for raising elevation, here for if I want to sample of the height, I can do that by holding the Shift key and then clicking on the terrain, and then everything I paint will be to that height from then on, so you can create sort of flat areas. Smoothing, pretty straightforward, just smooths out the areas. Pretty quick and easy to work with. You can change with the brush sizes and how strong those tools are from there. Terrain textures I will get to in a minute, but this is for how you sort of paint the appearance of the terrain. Trees. Now, there is a couple of things to note here, particularly this also applies to the detail section, which is the next one. When you use the Unity terrain for placing trees, it actually doesn't place the 3D models. Instead, what it does is it places edits a texture which basically contains the density information, so how dense the trees will be at this particular coordinate. And the good thing about that is it scales up and down depending on the computer's hardware, so we do in fact as part of our settings window, depending on where you pick on the sliders, will determine what or how many trees will render in a particular environment, up to the maximum that you see inside of Unity when you do development. The terrain trees also have the benefit that they do billboarding and instancing. You don't really need to know too much about what those are, but the good thing is that trees rendered through the terrain system tend to be faster than placing tens of thousands of trees in your scene by yourself. To do those, you just click Edit Trees, Add Tree, you pick a model. I think I've got one in here. I think there's a palm. Yep, that'll do. This is a speed tree. Just add that to the terrain, and then as we paint around, this is probably going to create quite a few, but you can see we can paint a lot. I'm just going to switch off this lighting. Okay, so it doesn't freeze up. And as you can see, we can get into these, and the detail and things is fairly high. And what it does is it'll actually bake down ones that are far away into a low level of detail variance, and then eventually billboard variance based on distance. But as you can see, you can quickly place thousands of trees and things very easily and effectively doing it this way. Details are similar to trees. They're intended for use for things that don't need to billboard, but just simply disappear when you get far enough away from them. Things like small rocks, pebbles, those kinds of little small detail objects you use the detailing system for. It can also be used for grass. So grass is usually just a 2D texture. So if we go add a grass texture, we'll search for one. We'll find one like that. That'll do. Just click add, and now I can paint with the grass, so I can go. Nothing particularly spectacular with how it looks, but it does certainly add something to a scene when you've got it. Certainly it's also worthwhile to note that the grass effect is relatively cheap. There are shaders and packages on the asset store for creating higher densities. One of the big problems with grass is that it's got something called overdraw. It's not so much a problem on PC environments, but if you're targeting mobile devices, which is something that we'll be coming to hopefully sometime soon, overdraw is a big problem there, so you don't need to worry about things like grass density in there. And there are ways around this using asset store assets if you want to get into that. Finally, we've got the settings window. Now, I probably should have gone to here first, but the key aspects here, you can set things like the width, the height, the terrain, the length, the resolution. I actually am not 100% sure what the maximum resolution you can set for a height map. I know it's in the thousands. It might be 8192, it might be 16384. Or it might be 4096. I'm not 100% sure on that one. In fact, I think we can even test. We'll get to that in a moment. So the basics of a terrain is you can have more than one in a scene. This actually can be useful. Terrains are storage-wise not terribly efficient. That is to say, we're storing every detail whether there's a change or not. So this entirely flat terrain, if this was a mesh, we could probably render from where my cursor is over here to where my cursor over here, and here as just a single triangle. That could be done if it was a mesh object, whereas for terrain it's actually going to render them at full resolution whether you want to or not. In fact, I'm not sure if we can see in wireframe mode a terrain. No, unfortunately we can't, but it will be rendering sort of the full grid, and it will be storing the full grid when it uploads. So if you have, for instance, a series of disconnected islands, it may be better to in fact represent the scene as 3 discrete terrains. They've got the small island, and that way you can leave the area that's not above the surface either absent or represented with meshes, or a single large low resolution terrain that sits underneath the smaller higher resolution ones. That's entirely within the realm of possibility. So today I want to cover off a few things. The first things are the terrain system, which I've just given a very brief overview of. The other thing I really want to get into is water systems. Now there's a couple of ways we can actually make really good looking water without actually having to pull in lots of third-party assets. I will briefly touch on a few of those third-party assets if we get time, because there is a lot of them for rendering water. Each of them has got their own sort of discrete niche where they work the best. We do support a wide number of water systems in space. The two that I recommend are either Sumono, which is probably good for high-end things, and then on the lower end, but also useful for things like still water bodies and things, is another package called Aqua S. Both of those two are the ones that I recommend if you're going to go with a paid water product inside your regions. Do check with us before you begin to sort of use heavy scripted assets from the asset store, because there are only certain ones that we do support in Sciencebase. We've added specific compatibility for a number of them, but others you may or may not be able to get them to work, so please do check with us if you have any questions about that stuff and it's not explicitly on our extensions page on the wiki. Okay, there's also a third way of doing water, or third and fourth, and those are the two free options, and they're not terribly bad options. And to do that, I'm actually going to poke around at our welcome center. So if you've been into our welcome center, the preview, you can see this is actually the version inside the editor. And I have a water system here that is not using a water system. We actually had a crash bug that we were debugging for a while. It turned out to be related to a specific facet of a certain number of water systems in the scene simultaneously causing a crash. That crash thankfully is now fixed, but one of the byproducts of it was that we needed to figure out how to get nice looking water without using something called grab pass refractions, and without using too much in the way of planar reflections. So what we actually came up with was this, and this is a plain 2D texture using our standard shader, which you can see here, and one of the neat little perks of this is that we have got an animation on it, and we record an animation that actually animates a normal map or a bump map on the object. So actually you can see here, I don't know how good the frame rate is for our streaming viewers, but hopefully you can see that there is sort of some level of depth and detail to it. And if you take a look at the material we're using, which is helpfully named non-crash, you can see that we're actually offsetting the tiling animation. We're actually animating both of the primary normal map, but also the secondary detail normal map, and we've got both of them animating at different speeds and in different directions, and that actually gives us a nice effective looking water. Now the perk of doing this with the standard shader, which is what we've done here, we've just used a normal standard PBR shader in the transparent mode, is that it picks up on reflections. Reflections baked through reflection probes in the scene actually get their reflections in here, which gives us a high quality reflection on the water while not incurring the performance penalty that some of the more heavy water packages incur. So the quick answer on how I built this, I can show you. I have grabbed a new material. I have set the shader to standard. The mode is transparent. The albedo is completely transparent, so there is no base material, and you can see if we wrap that up, you can see the difference of what's going on there. And we're in fact getting all the reflection, the appearance from the metallic value. The metallic value actually leaked a little bit of actual sort of visibility into the water texture. And then we've got it very, very smooth. It's not completely smooth. As I pointed out in my lighting tutorial, having a smoothness of 1.0 can give you sort of really false, bright specks. And that may be what you're going for if you're looking for something that's glistening. But in our case, we don't really want to get that. So if I actually pull this in with the post chain in here, I've got a camera in here already. I'll show you how it looks with the bloom. Yes, I do have a camera. And I will just add a post processing behavior with our post for the welcome, and it should be here. So now you can see how it actually looks in the viewer, which is not too bad. It's actually quite nice. So as I said, the main attributes are that it's transparent. It's got the little bit of metallic, very smooth but not quite 1.0. And we've got a normal map attached here set to 0.5. Now this is just using the Unity 4 one that comes with the standard assets. It's called Small Waves. The bump map is just that, nothing particularly special about it. It's the one used by the Water 4 assets too as well. So we go back to our material. We've got that included twice, so both in the normal map slot and in the secondary normal map slot. And we've got them both set to 0.5, and that means that at the peak they should add up to about 1.0 when they're merged. The tiling values are a little bit different. We've got the main one is a slightly small tile, so you can see it's set to 14, and that basically just gives the small tiny details. We can set this up higher if we wanted to, but we do have to be careful about avoiding repetition. And then finally the secondary one is tiled a little bit looser, so it's at 8, so it's a larger wave. Now in the animation, you'll notice that we've got, we actually animate them from 0, so they're both 0. This one runs after 20 seconds approximately, 19.5 seconds. It runs that the main one moves 4 tilings, this one moves 3 tilings over 20 seconds, and this one moves in the opposite direction because it's -1 at half the speed. And basically the net result of that is we get a sort of a nice glistening water effect that's fairly cheap, just using Unity animations and the standard shader. Nothing particularly special or fancy, doesn't require any scripting, looks good, gives you a good result, and it's very cheap to render compared to some of the other water packages. We also in this scene use another package called Sumono, which I did discuss as a third party. Now I'm just going to quickly save here because this region has been giving me some trouble. But let's have a look. And sorry, Unity does take a little bit of time to fire up the first time I do it in a day's session, which I think you've seen from previous tutorials. So this one's a high-end water package, and the perk of using Sumono, which is the one we're using here today, is that it's a very high-quality effect. The quality is significantly better than the built-in Water 4 package, which I'll also go to in a second. It gives us a lot of tailoring and customization options. I might even be able to pull this outside if actually a sec. Get back to normal. It's all about offline previewing stuff. Okay, so let me just grab the Sumono. That might be, yes. So we actually have in this particular scene at the moment, we've got a splitter here, which actually you can see that we have exclude object sets. We actually pick between Water 4 on mobile and WebGL, and then we use Sumono on desktop. You can do that using the exclude object component. That lets you just specify this is only going to appear on desktop platforms and desktop clients. Gives you a bit of control over exactly how things go. And it'll also be excluded on the processing server, so it won't be included in the file size. But I'm just going to turn it on manually here. I'm just going to grab these guys, turn them on manually as well. And with a bit of luck, we'll have a water package. Now, I don't know if we're going to be able to see this, so I might just look at my Sumono test. Let's use one of the demo scenes if I have to. No, I will not save. So this is one of their pre-packaged demo scenes. Now the water system, when you particularly apply all the other effects and things that come attached to it, we can actually have a look here and see what this looks like at runtime. It has a lot of nice little things like bumpiness, it has elements attached to objects, all those little extra tricks. They should work in space. You have to stick the whole package. Conversions listed here. You can see that it's a fairly nice looking effect, particularly that underwater. It also comes with a whole bunch of packages for moving between various modes. Fairly straightforward. Go to the preset manager here, you can sort of see that there's everything from Caribbean to rivers and other kinds of water assets. You can get sort of nice deep ocean effects and things as well. Certainly worth playing with. It can be a little bit pricey, but if you're doing stuff with water, it's not a terrible pick to go for. The other option to compare for ocean water is one called Playway. Playway has been giving us a little bit of flack sometimes, but it's not a bad option either. If you do have problems with it being supported, again, please just contact us, because we are looking for some more demo cases and things to make sure it's behaving the way it should, as we've had to manually integrate that one. Now, going back to the test scene, the final one we can look at is one called Water 4. This actually came with Unity 4, so it's a little bit older, but it still doesn't do a bad job. And you can see here that we just bring this to a scene. Hopefully you can see it here. You can see it's not a terrible looking water option here. It does give you refractions, it does give you reflections, it gives you all those sorts of things. It does, however, come at a performance cost, particularly if you've got the planar reflections enabled. How planar reflections work for the purposes of these systems is they'll actually render the scene twice. They first render the scene from your camera perspective, and then they'll render it from a reflected perspective as well, that will then be mapped onto a texture and brought back into the terrain before final rendering. This is quite expensive, especially if you've got the reflection mask set to everything. That will mean everything in the scene will be rendered twice while the planar reflections are on, and it's basically an easy way to halve your frame rates. So something to be careful of is the planar reflections. Just simply unticking the component. You're not going to notice a huge difference in the quality of the water, but it will double your frame rates. It depends a little bit on what you want to do, whether you want to use those components or not. We also have the settings. If the user are on a low-end system, we actually do switch off those planar reflections as well, automatically as part of our performance management that we can do to ensure that all the computers are okay. So we've got the basics of water covered. I think that probably is enough for a brief overview. I saw a question in the chat asking about underwater systems. There's a couple of them. AquaS has an underwater module. We've had to switch it off due to a bug, but we're hoping to fix that at some point in the near future, and once that's fixed, it'll be permanently fixed. Sumono also has an underwater module, which is quite nice. I would say of the two of them, Sumono's looks better than AquaS's, but they're both sort of, or Aquas, they're both sort of easy options to work with in terms of giving instant underwater looks. You can also just consider using post zones and things. You can just make a post zone that people walk into that sets things like the color gradients and things. You can use the tone mapper to make an underwater looking environment. You can change the lighting, remove the exposure on the camera. All those sorts of things can give you those sorts of effects as well. It depends a little bit on what you're doing, whether you can have the camera going up and down above the water constantly, or if it's a one-way teleport, which method is the best, but those third-party assets do actually cover it to a degree. So let's move on to terrain and a little bit more about terrain. So I have a couple of things on my agenda today, which I think is worth touching on. The first is importing terrains. So while we've got all these fantastic tools in Unity that we can use for painting terrains, they are also not as good as some of the professional tools out there. So at risk of sort of sending people to third-party tools again, there is a couple of high-end terrain tools that I think are within most people's budgets that are worth looking at if you're going to be using terrain stuff constantly. It's kind of like licensing Photoshop. It's one of those things that you sort of have to do if you're going to be doing this stuff as a relatively large percentage of your free hours will work or anything else. Some of those tools aren't bad. The two that I like to use is there's one called L3DT. It's been a couple of years since I've had to use it, but it did a really good job of procedural generation of environments. The other tool I like to use, and is probably my preferred tool, is one called World Machine. Now I haven't updated my license in a while, so I'm running a little bit of an old one, but I've actually got it open in the background here. So we're just going to go in here. This is a World Machine sample, so I've just pulled up this one called Island with Mountains and Lowland. It was in here, I think. So this is the basics. It's a node-based editor. So if you've used Map Magic in Unity, there's some asset store utilities. I'm going to get to those in a minute as well, because those are built into Unity and make life easy. This is just a simple node-based generator. It's got fantastic erosion and other kinds of facilities built into it. But the net result is you can sort of get a nice looking terrain fairly quickly in here that will build at the resolutions and things. We're actually going to build this one into our test scene over there in a minute that we've got in Unity at the moment. So one thing to watch for when you import terrains is edges. If you notice here, we've actually got the area of the terrain is running off the edges. Now, if this is built with layout nodes, which is in World Machine, which is what this is, you can go here, click to Overview when you're in the layout mode. You can edit the bounds of the environment. So we're actually going to expand it a little bit so we've got flat edges around the edge, and that way we can sort of transition nicely off it. So if we go back into the 3D view, you'll see that we've got it all nice in there. So I'm just going to change a couple of the settings. I'm going to bake this one at 2048. Actually, I'll do it at 2049. And I'll just do all those settings there. Now, to get the appearance of... So I'll just render this one quickly. To get the appearance that we've gotten here, where the terrain has grass, mountains, that kind of thing, how we can represent that in Unity is done... And actually, I'll do this while I wait for that one to bake. So we came back to this terrain texture thing before. And what we do is we just add terrain textures to the environment. So if I go for grass, just go from there. Oh, actually, that one looks a bit nicer. What I'll do is I'll also add a normal map for it. We'll just add that one. Now the first one you put in will become the default, so in this case we've just sort of textured our terrain. We can add as many of these as we like. A rule of thumb though, I'll just grab a rock. When building these things, you have to add them in multiples of 4 for optimum performance. So every 4 textures you have, you're going to add another rendering pass to the terrain. So the fastest terrains will have 1 to 4 textures. Then the next fastest will have 5 to 8, 9 to 12, and so on and so forth. Every time you do that, you add another pass. Now the passes aren't too expensive, so honestly it's not terrible to go into the 8 and 12 and 16 or whatever. But just be aware that every time you cross over one of those multiples of 4, you're adding a little bit of a performance impact. So if you're on the edge between adding a 4th or a 5th one, go for the 4th. But if you're deciding between 6 or 7, it really doesn't matter. Go add the extra one. So now we've got a terrain in here. I'm just going to add this guy. Add an extra texture. What we can do is we can actually just paint directly onto the surface. We can paint that this is getting a bit of mountains and so forth. Now, when we bring a height map in from another product, there's 2 ways we can approach it. The first is that we just decide that we're going to paint it in Unity. There are some third-party tools as well that can sort of speed this process up using automatic painting and things. There's even a bunch of open source assets that do the same thing. So if you go Google around, there's a site called UnityList. It's unitylist.com. They have a whole bunch of third-party tools for Unity. We support quite a lot of them, especially if they're editor-only features. They're almost guaranteed to work. So those can be useful. But when we go into World Machine, we've actually already got most of what we want here. Now, I'm not 100% sure I'm porting this one in, but we can see we've got some decent layouts and things already. So what we're going to do is we're going to make a splat map. Now, a splat map is what this is actually looking like on the underneath. So if we go find this terrain, which I can do from here. I don't know if yes, it won't let me just save it quickly. I'll just save this scene. We've got terrain. And you can see that now we've saved it. We've actually got the splat map in there. You can see this is the texture of how it's actually rendered, and we can swap that texture out with something else. Now the process to do that in World Machine, I believe we need to add an extra extra filter that comes in World Machine. I need to remember where they are. It's in macros. Basic splat map. That's the one. So we can see here, this will produce a map similar to the one we've got inside Unity. So I'm just going to pull this onto here. This is where our height map is coming from. This is our erosion input. And we're going to output to a bitmap. Just copy that bitmap output. And we'll set the alpha to there. And what we'll see here is when we look at it. So I'll just unlock this view. I need to remember where all these tools are. It's been a while since I played with it. So I'll just render this quickly. And we can't really see that because of the alpha channel there, but I'll remove this one. Should be okay. Yeah, there we go. So now we can see this is basically what this height map terrain will look like when it's turned into a splat map. Similar process, looks fairly basic, but what we can do is we can just export this. So I'll just grab that back in. I'll specify this as a output scene, so I'll just find out where this is. I'll just export this out to here. Start the talk, and I'll just write the output. And I'll write this height map out here as well. And then when you export from World Machine, you want to use RAW 16. That's the format you want to play with, and that's 16-bit precision floating point files. We'll just call bring this into here. Terrain for talk, and we'll just put .raw as the file name instead of .r16. That's just so you understand what it is. Okay. I thought maybe it's forced in here. Okay. So we'll go back to Unity, and we've got our terrain and our splat. So to import a height map, just simply select the terrain, click the gear icon to go to the settings, and at the bottom there's import raw. If you've got raw files from somewhere else, you can bring them in using this method. So I'll just go, firstly, I'll just bring this terrain for talk. And you see it brings up this import mode, and we'll just set the mode to bit 16. If you've got 8-bit raw files, which might be common elsewhere, you bring them in as there. 16-bit is generally recommended though. So finally, we'll just bring this in. Now, the last thing we need to pick is the settings. So this one is actually quite a large terrain in World Machine. In this case, it's a world extent is 96 kilometers. So we're going to scale that down. We're going to make this a 9.6 kilometers. So we're just going to divide everything by 10. So the size will be 9600. What's the height? This might still look huge. And the set up. Okay, the elevation here is 576. So we'll just set this to 576 meters. We're divided by 10. So the y is going to be 576, and this will be 9600. And this, when brought in, should modify our terrain. So we've now got a huge terrain, which basically represents what we had in World Machine. Now, as I said, because we don't have the splat map, it's all going to come in as grass. To import the splat map, we just need to import the detail resolution. It's the same thing. So 2049, 2048, I got behaves. I'll set the base text resolution. When you import with the splat map tool that I'm about to show you, you do need to make sure that the detail resolution and the base text resolution are both the same as the height map resolution. If you do it from within Unity, you can get away with not doing that. But I'll just save this. And finally, I'm going to grab this terrain, grab the splat map. Now, where's my splat? Splat for talk. So this one's 2048. I'm going to set the mode to read enabled, and I'm going to set unchecked sRGB. And when I do both of those, it'll prevent it from being affected by some certain color grading that Unity will do on textures, and it'll also let us read it from code. So finally, we'll just go back to the terrain, go to the splat, we select the splat, we go space, tools, content, terrain, and then finally replace splat map. And now we can pick splat for talk, and hopefully this behaves. With the splat map does not match terrain. What's the terrain? Sure those things all line up before we do this. There we go. Now we can go space tools, terrain, content, terrain, replace splat map. I'll just go splat, grab this one, and with a bit of luck, I need to set the terrain to readable. Sorry, I've done this for a few days, but it will at least tell you what's going wrong each time. So the last thing we need to do is we need to set this to, we need to no compression, and we'll just set the mode to, I might need to grab the official tool from World Machine at some point, because this is based on their tool, but it has been a while since I've used it. So we have space tools, content, terrain, hopefully this is the one that gets it. And that might need some maintenance, I'm afraid. Always the thing that happens. That should normally work, and we'll issue a small editor patch to make that work. But what we can do is we can actually grab it off the World Machine website. They have a version of it. So if we go to the World Machine, let's grab a Chrome window. We'll go World Machine, Unity, Splat. It'll give us a page with a link to download. So we'll just grab the tool I've got. There we go. World Machine Splat Map, and we just bring that into the project if we want to. A little bit annoying we have to import this ourselves, but at least we've got the options to do so. So let's grab here. Let's grab from here. Assets editor. I'll just drag this into this editor folder. There we go. Replace Splat Map. Give it a second to run. we should have a tools option. I believe that's where this one will go. Maybe it goes in 1 second. We'll just find out where the thing goes. Okay, where is it? It's I should be looking somewhat obvious, but it goes in the terrain menu. Very obvious. Okay, so I'll just grab this one. Let's grab our splat. And this might need a small modification, I suspect, depending on how this looks. It looks like Unity have changed something in 5.6 that will need to be updated. Yes, so what I'll do is I'll just quickly make an edit to this tool. Hopefully it won't take us more than a second. It's unhelpfully checking something it shouldn't. Okay. Sorry about this. It's always fun in the art classes to have to fix something up, but basically the tool is Unity have changed around how texture formats are labeled, so it's instead of RGBA it's now ARGBA, and we can quickly switch this one. We'll switch it in our tool as well, but the process here it'll swap in the texture, and it'll bring the splats that we built in Wild Machine into here. Now we want to move on next onto some of the other tools that are a bit easier to use than this process. This process is a little bit messy. We can just have a look here. We'll find and not equal RGB24. Aha. Okay, so we could have used our other tool. So the key here, you don't even need to fix this. You need to go from here, set the mode to RGB 24-bit, and just bring that in. And now we should be able to go terrain, replace splat map. We'll just put the splat map here. Sorry, we'll put the splat map in there, and we'll grab the terrain collider based one. We'll just put that into there, and we hit replace. And we have something. Let me just quickly make sure this is all. We've lost our texture, so I'll set the basement distance. Now we should have this. We might need more. So I see some touches on that. I do also like the fact that we've managed to move our trees around the place. I may pick this up next week. I'll have a play with it and give you guys the best method of getting these things in, because there are actually also third-party tools that sort of handle this process in a little bit more of an intuitive manner. So one of them is Gaia. If you are familiar with it, it's actually one of the sort of award-winning assets on the Unity Asset Store. And if you want to touch terrain, it's not a bad option to pick from. So I don't know if we've got any samples in here in the Gaia directory. I may or may not. So I won't cover this one offhand because I do need to build some samples. But it is a tool that's built into Unity that you can go create object to create a terrain. I believe we just add Gaia components to it. It's been a while since I've used it. Gaia session. I think that'll do it. Yeah. So now when we bring in Gaia, it'll actually do some stuff with what's called stamps and let you place stamps of objects and things together onto the terrain and build the terrain that way. It's a pretty good tool if you're actually going to be building procedural things, but unfortunately I will need a bit more prep time to give you guys a proper demo of Gaia, but I do recommend checking out some of the videos and things in the asset store on building it. Finally, we will talk about, so we've covered off those terrain texturing. Okay, so the next one we're going to cover off is how to make your terrain look better. So let's say we've done the work to actually get our terrain in. We've got a nice looking terrain. Often just painting it by hand is not a bad option. You can whip together a quick terrain fairly easily using the Unity terrain tools that are built in without going into any of these extensions pretty easily. If we just go back to the Welcome Center, I'm just going to find where it is. It has had several names by our artists. I think the release one is this one, Welcome Redux #1. Just as a general rule of thumb, if you're doing art, SVN is a really great way of working across teams, because it means you don't need to end up with these 4 variants of the scene they're seeing in one project. Unfortunately, this one I've grabbed off people. This one I don't think is our copy. It looks right. Oh, that's because we've got some rhino in here. Okay, and also because we've got, this is done with substances. I was wondering why that's all giant and blue. It's because it's still baking the substance values out. So if we go into here, we've actually got a custom terrain texture on here. So I'm just going to pull the fancy image effects off the camera, and just so we can see the terrain underneath. So one of the things you might notice with this terrain is the blending between the objects. So what you'll notice is the grass is sort of scattered onto it. It's not just sort of smoothly blending with transparency. So when you've got these leaves, the leaves themselves have a little bit of height and things attached to them. You'll notice that where we blend the sand into the rocks, it's going to follow up the grooves. Now, the way we've done this is two things. First, we've used an open source shader I wrote. It's on GitHub. I've also posted it into the forums in the resources thing. You can just bring it in straight in. And this is our terrain height map blending shader. And it's one that I built. So what you can see here is we've built this one. It's called Atom Height Blend, and it basically lets us import height map data on top of our normal data on the terrain. So when we select the terrain, and why have I lost my inspectors? I do not know. So if we grab the textures that are in this one, so I'll just grab, I don't know what I've done. Today is a day for things to break. This is not your fault. This won't happen in your editor packs. This is my private editor pack has thrown up. I've really got to stop using them. So if we bring in the terrain, we'll try and find it. I think this is the one we're using. I'll just see if I can pull in the terrain data. See the terrain data with you. I'm just going to reopen this one while we wait. So this terrain shader basically gives us full blending, and I'll switch it on and off and show you the difference between the various modes. And the terrain blending is some of the higher end terrain texturing packages. There is a bunch for Unity again. I won't push constantly to the asset store, but there are a couple called Relief Terrain Pack is one. The CTP shader pack, which is also from a guy who makes Gaia, is also worth looking into. Both of those give you sort of really high quality crisp terrains. The problem is that one, you need to fork out a bit of cash to get them, and two, they are quite rendering expensive and won't work on lower end devices, including WebGL. So what I've done is actually write a terrain shader, and hopefully this will just take a second to pop up. And the terrain shader that I wrote basically gives you height blending, it gives you PBR materials, but it doesn't give you anything more than that. It doesn't do tri-planar texturing and a few other things that can sort of make your shader pop a bit more. And the reason I haven't done those things is specifically to allow for it to run on older devices and to not choke the frame rates and things that can come with more complicated shaders. So here we go. Hopefully I've got my inspector back. Yes, I've got my inspector back. Great. Sorry about that. Just give it a moment to reopen properly. Okay. I think I've got it. No. Just 1 second. Okay, so we've got our terrain textures. So now if I actually look at my terrain textures, what you'll notice is the first thing, and I'll show you this both off and on, but I'll just show you the details. In the grass itself, you can see here this is the normal grass texture that's just applying here. You notice it's a bit spotty, and the reason is the alpha channel has got height map information encoded into it. So if you're using a tool like Substance Designer to build your textures, you can export the height map for free. In this case, I just built it from the grayscale, so I cut and pasted the red channel, I think, into the alpha channel, which produces our height. So it reads from the alpha channel on the texture to determine the blending. So when you look through, for instance, here the cracks are visible, and to look at that, we just go to the texture, find the texture. This one I think comes from one of our friends over at gametextures.com. You can see here again we've got the higher bits are white, the lower bits are dark, and the sand is going to sneak into those. Now if we switch the custom shader off, and I'll show you how to use this, what I've done here is I've got a custom material attached. So if I go to the built-in standard, this is the normal PBR shader, you can see immediately the difference. This is how it blends, so it's just blending naively, it's just transparently mixing between the two. Doesn't look as good. Oops. So we'll have to find our terrain terrain height blend. This is our one. So to do this, to use this shader, all you have to do is create a new material and just apply a shader to it. So in this case, you just go create new, custom terrain shader, and then you can use the normal shader inspector up here to add. So in this case, it shows up as nature terrain standard height blend. So just go nature, should be right in front of me, there we go. Nature terrain, and we've got standard height blend, and this is the custom one that I wrote. And then when we've got that slotted into the slot here, so if I just leave it as blank, it'll use the Unity default, but the moment we put our custom terrain shader in, bam. Now you can edit these shaders as before. There's lots of open source terrain shaders available as well. Again, unitylist.com is the place to go to get them. But it'll give you the sort of the nice blending effects and things that you're seeing here. And it's a relatively straightforward and simple thing to apply, but it means that when we paint, we'll actually start painting the height map grooves. So if I go back to this one, just going to paint a little bit, and this is actually going to be in a live region, so I haven't checked my stuff into SVN in a little while, so I'm just going to keep my brush size small and just paint a little bit slowly. You can see here that as we paint, it fills the grooves and around the rock first before it actually overwhelms the rock. So I'll just undo that. Fairly straightforward. And this is sort of giving, again, a little bit of the power of what you can do with shaders. I mean, custom shaders are an extremely powerful tool that you should be taking advantage of. It doesn't take a lot of work to learn how to use them. I have covered them briefly in one of my previous masterclasses. I think number 4 covered the creation of custom shaders, but here it's just the same as all the others. I mean, you can poke into it in the text editor and see that it's fairly straightforward. One thing worth noting, if we're going to discuss custom shaders and how I built this very briefly, all the Unity standard custom shaders, all the Unity standard shaders are open source. You can download a zip file containing all the Unity shaders. So if you just want something to learn from, to make small tweaks and things to the shader, you can. In this case, it was copied entirely from the Unity one, and then we added height map blending and a few other things just on top to make it fairly nice and look good, but still maintaining all those core attributes that Unity have worked hard on, like PBR rendering and things on the shader packages. Okay, so we've covered through actually most of the things that I wanted to get through to today. So what I might do is I might actually open for some questions and see what people are curious about learning, and then maybe we can work on to what else that people want to sort of cover on. I can certainly show off some of the third-party tools and things as a possibility, and anything else. So I'll just leave this for a second, and I'll fiddle around with some of the other tools while I'm at it. Oh, sorry, there's actually one more thing that I wanted to cover beforehand. I had a question before the thing today on how you can get real-world terrain data into here. The best way I've found, as far as convenience goes, is a tool called terrain.party. It's just a website. You just go to https://terrain.party, and it'll let you basically cut out an area of real-world terrain. In this case, it's not terribly far from me. It's just out in the Blue Mountains outside of Sydney. So I've just grabbed this section here. You download a package. This is from the Blue Mountains National Park. You can just grab the package. Okay, and I do have a couple of questions, so I'll get to those next. You just grab the texture, the package. It comes in as a raw file, which you can import into Unity onto the terrains as they are. So in this case, I'll just grab this. I'll get a new terrain handy. Let's save. Game object 3D terrain. Back here. Blue Mountains terrain. Okay, so we've got the height maps here, which you can see are just, I think they're coming in as bitmap. They're the PNG. Okay, so hopefully we can import that. We might need to convert it to a bitmap first, but we'll have a look. So this is terrain.parties stuff, so if we just go import raw, what format can we take? Okay, we can only take raw here, so in this case we'll need to just export it in Photoshop. So just open it up in Photoshop, we'll go File, Save As, and we'll just save it as a raw, and we'll just save it in the right directory. So we'll just grab here in this project, let's grab this one. And we'll just set it as a raw file, so it's just Photoshop raw. Will hopefully give us the details. So you just leave all this stuff blank. This will come in as an 8-bit. Now, terrain precision, there are some better ways of getting higher precision data in. The USGS has a website that will let you download DEM data, that's DEM, which stands for Digital Elevation Model. That model will be higher quality and will give you less, I guess it would be terracing as the closest analogy. When you use 8-bit raw files, you'll find that terracing does become a problem, whereas the full 16 or 32-bit ones are ideal. But in this case, I'm just going to grab my Blue Mountains Raw, and I'll just bring this in. This is an 8-bit one. What resolution is it? Just very quickly, I want to go back into Photoshop. Window info, and it is. I've just moved onto this computer, so I apologise. I don't actually have a pixel resolution on this, because Photoshop likes to default to all sorts of weird standards. Okay, so looking at pixels, and hopefully that. Okay, so it's 1091. It is 1091. It's a bit unusual. Byte order Windows, and we'll just import this all as is. Although that looks like I've miscalculated that one. Maybe it's a different format. Sometimes you have to play around with these settings a little bit to get the specific data in. So let's grab this one again. So byte.mac. So there we go. Okay. So in this case, you can see that the data is quite wrong in terms of the width and height. I'm guessing that is, it says 30-meter resolution, so it's 30 meters times 1081. So this tall terrain is 32 by 32 wide. We'll set a width to length to that. Okay, so now we've got the real world terrain. It's probably roughly to scale. I'm not 100% sure what height elevation it has, but let's see. So it's 65 to 909. So if we just set the height value here, so if the base value is 65, it's just going to be 909 minus 65, 934, which I should be able to do in my head, but I can't at the moment. Okay, I'm going to bring that in. Okay, so this is now accurate to what the terrain should look like in the real world. Fairly straightforward process. We've just got a grass, a little bit basic, but here we go. We've got a basic real-world terrain. Now you will want to paint the rocks and the trees and the sand, all that kind of stuff on, or use an automated tool to do so. If you use something like World Machine, you can export a splat map, which you can bring in here. The process there, you will want to just read up on the World Machine website because it's got the full information. But you can certainly see that we've brought the terrain height map in fairly quickly and easily. Now I had another question on voxels. Now, voxel terrain is a different process entirely. You do need to use a third party here. There is one called Voxeland, which is the one that I recommend. It works with another tool called MapMagick. If you're going to be using a node-based editor inside Unity, MapMagick and Voxeland do work well together because they're from the same author. I'll just wait for this to load. Hopefully I can import it into the package in the next sort of 5 minutes because this is another tool that's sort of worth covering off in how to make voxel terrains. It's really quite powerful. I've got it in a few of my other projects, but unfortunately none of them are on this computer, I think. I'm just going here. We'll grab it from here. I've got the Voxeland in here. This Unity asset store can be really slow sometimes when you've got a lot of assets, so I do already have it, so I'll just cancel that. I'll just bring this one in. Now, this tool is one that I actually like to use. I've got a couple of regions that I've been using Voxeland for. The tropical island scene, which is on live, is using Voxeland for its voxel terrains. There's another one called Voxeland Test, which is just a basic scene, but it's not a terribly bad one to poke around at. So just wait for this to import. And while I'm doing that, I do see another question about weather and environment. So we have a custom sky shader. I can even cover this in a future tutorial, which will give you fairly high quality skies and terrains. Fairly high quality skies with multiple interacting cloud layers. We also do have Fog Volume 3, but we are fighting with it. We have an update due to it, which will be in the next viewer release, that will hopefully finally solve some of the problems we have with it. It's got a problem when you need to use it in modes where it's got Z testing, that is to say that it interacts with the environment as a full volumetric cloud system that you can fly through. If you don't need that mode and you switch the depth testing mode in Fog Volume to ignore Z, then it does work a bit more reliably. That said, though, if you do want to play with fog volume, we do have it in the whitelist, and it is something that can be finangled into working, but it requires a little bit more hair pulling at the moment that we would really like it to. So I'm just waiting for this to come in, because voxelland is quite a cool tool. So if you're doing anything to do with voxel terrains, this one is one to go for. It's very well built. It'll give you sort of all the options for burrowing caves and caverns and build floating islands and all that kind of thing that you don't really get with a normal 2D height map. And they're not bad. Sorry, it's not a bad tool. I think that on sale it typically goes down to sort of $50 or so, which is a little bit of money, but it's not terribly bad if it's going to be a staple workhorse of the kinds of regions and things that you're looking to build. Certainly it's well built and worth the money. I can say that for a lot of the things in the asset store. They do tend to be a little bit pricey, but the quality you can achieve with those tools is just far beyond everything else. So to create voxelland, I can show you a little bit of a demo of that one. I think we create a new 3D object and it's a voxelland. Yeah. So we'll just create a static. Now when you're doing voxelland, create static objects, not infinite. The infinite ones will not work. And that's because they require procedural code and things running on the client. It's not in our whitelist. This is purely as an editor extension. So what we've got here is just a basic voxel terrain. Now we can so we can texture. So we'll just grab a grass, set this one to grass. We'll grab another land block type, which is going to be our rock, and we can. I'll just set the mode to bigger. Blob. There we go. So this basically just lets you paint, but unlike other terrains that are flat, we can actually make not only caves and things, but we can paint in full 3D. It's a pretty good tool. It works pretty well. Now, one of the things you notice with voxelland is that it can be a bit blocky. You can see sort of as this, from a distance, it looks a bit Minecrafty. You can change that around with the smoothing settings. So there is actually relaxation and strength iterations here. So we'll just set this to set the relaxation strength quite high. So that's 3.99. I think you need to even set it a bit higher for this to fully behave. But we'll just do a rebuild. It'll smooth out quite a bit. So now you can see we've got less of that blockiness happening. Still have it sort of a distance, but you can increase these values until you're happy with the amount of smoothing versus what's going on. So this is a really powerful tool. It also exports just as meshes. So things that work on meshes will work on here. You can add custom shaders. You can integrate it with things like Relief Terrain Pack. We've successfully done that with a creator region. You can carve into holes. You just hold down Shift. Where's the control? Yes, sorry, hold down Control to dig, and you can sort of dig into the terrain and make whatever you want. Definitely a worthwhile tool. In fact, let me just hold this down. Definitely a worthwhile tool if you're going to be doing things that you want full 3D terrains and things attached to them. Not a terrible choice. Okay, so just going back for further questions. Weather systems. At the moment we don't have a direct weather system, but we do have a built-in day-night cycle that's got quite a lot of options that are configurable for doing that kind of thing. To do that, you just create an empty object, search for day-night. In fact, do I have the editor pack imported in this project, because that would be a good starting point. Yes, I do. There we go. Don't know why that didn't show up there, but for this one, it's pretty straightforward. This will actually let you, in the editor as well, preview it. So we just grab the direction light for our sun, we'll just drag that into there. Preview enabled, and now we can go, you sort of see the full day-night cycle there. This will work with both the Unity custom shader and our own Cloudbox shader. I can show you that one. This is our customs, I think this is imported into there. Yes, this is my personal cloud shader, environment shader. So you can see here that it sort of gives you a little bit more control over the skybox. Has stars and things attached to it. It makes it look a little bit nicer than the built-in Unity one. So you can see here at night, everything's pitch black. Go through the day, clouds and things will behave correctly. Generally speaking, the combination of those two can give you a lot of what you're looking for. Now, if you want full weather, I would look into things like Shuriken, the particle system attached to Unity. You can do quite a lot with that. You could combine that with quite a lot of scripting and things to create sort of various weather effects fairly realistically. I would also look at things like global shader properties, because you could expose, for instance, a global shader property that has like wetness, and you can have wetness maps and things on your outdoor streets. It's more of an advanced feature if you're getting into this, but certainly it's something that has a lot of power, and perhaps it's something we can cover in a future class, how to do those things. Nonetheless, I hope this was all useful. I will see people in World in just a moment for the office hours I'm about to run. Hopefully this has been a useful sort of educational overview on how to get terrain and things going. Next week I have a couple of topics. I already outlined that I'm looking into poly either covering vehicles or clothing. I do want to get clothing in at some point, because I think there's some more sophisticated features and things that people aren't using yet that I would like to cover on too. And it's a good excuse for me to make a bit more clothing for our libraries as part of our office hours process. But if you have a particular suggestion for a topic or things, please let me know, because I am open to at least some suggestions on what we cover on these, as long as it's something that will be broadly useful for a large number of people. Alright, thank you very much for listening, and we'll be back same time next week. Fantastic.